Thank you, Keith, and kia ora koutou katoa. Thank you to the Royal Society, Te Aparangi, for this fellowship and the opportunity to tell you something of my life and research. I've chosen the theme of interfaces for my presentation as I hope to reveal some links between my varied life experiences, starting with my core discipline, electrochemistry. Now, electrochemistry is literally a science of interfaces. It combines the world of physics and electronics with that of chemical reactions, and it is the electrode or interface where the oxidations and reductions occur. One thing that has always attracted me to electrochemistry has been its central role in so many technologies associated with clean energy, from solar panels, green hydrogen production, through to electric vehicles and all our modern devices that rely on lithium-ion batteries. My lectures are full of these examples and how we might improve these technologies. But I always ask my students to consider the environmental costs of producing the materials required, which shouldn't be overlooked. And there are other industrial applications of electrochemistry, such as the production of alum metal at Tiwai Point, using about 13% of New Zealand's electricity production. This may or may not soon come to an end, and consideration is being given to using this electricity to produce green hydrogen fuel, again via an electrochemical process. And there are some important decisions to be made here about how our electricity supply should be best used for the future. But one of my favourite examples of industrial electrochemistry is less well known, namely the very fine and detailed deposition of metals as part of vinyl record production. The record grooves need to be very finely printed to recreate, whoops, I went too soon there, to recreate wonderful musical sounds. And this provides an interface to a lifelong passion I have for piano music and the very sizable collection of 78 and vinyl records I inherited from my parents, who met here in Wellington working for his master's voice, HMV. Some of my main electrochemical contributions have been in the area of beverage analysis, particularly with wine. And this has involved trying to improve an older measure for wine oxidation status, only to conclude that it does not measure what everyone had presumed for over 80 years. Trying to convince wine scientists of the need to rethink the redox potential measurement has been a gradual process over 30 years. And it's the one case where I've reflected upon Karl Popper's theories of falsification as I try to devise experiments to support my case. A newer approach that I have developed using cyclic voltammetry has well and truly taken hold, with over 15 wide labs around the world now using the technique, and commercial systems have produced, unfortunately not by myself, for use in wineries. The interface with wine has continued through a whole series of research programs involving multiple researchers and wine companies. Several of these have centred upon understanding the outstanding aromas of New Zealand's Sauvignon Blanc wines. And some of our most important findings, which somewhat contradicted established wisdom, were that the loss of aroma over time in the bottle is not mainly an oxidation issue which you can solve with screw caps and inert gases of bottling, but it involves a different process which is highly temperature sensitive. And as a result, many wine companies now hold their wines under refrigeration prior to bottling. And as a take-home message, I'd say if you find a Sauvignon Blanc wine you really like with those intense passion fruit aromas, that's the one wine you would store in your home refrigerator to have it best in the future. In fact, where oxidation is instead critical is in the phase between the world of viticulture and the realm of the winemaker, namely the few hours it takes to harvest the grapes. Surprisingly, machine harvesting helps to create more of the aroma compounds, and most critically, antioxidant additions at harvest, using sulfites and ascorbic acid, make the difference between a complete lack of aroma compounds and an abundant amount. Our most recent finding has been to demonstrate a role for yellow elemental sulfur, which is used as a fungicide in the vineyard. And I like to make a link between the smells of two of New Zealand's most famous tourist experiences, the sulphur of geothermal pools and the passion fruit aromas of our New Zealand Sauvignon Blanc wines. For my PhD in the 1990s, I was introduced to the electrochemistry of conducting polymers. These were the polymers that Alan MacDiarmid discovered could be made highly conducting, leading to the Nobel Prize in Chemistry in 2000. I've worked with conducting polymers extensively, particularly as electrochemical sensing elements. We also showed that conducting polymers could be regarded as solid antioxidant materials to combine with thermoplastics for use in food packaging. More recently, we have moved away from materials like these, which are not entirely food safe, to work with antioxidants derived from horticultural waste streams like the grape marc left over after winemaking, and incorporate these into biopolymers, moving in the direction of biodegradable packaging. At this point, I'd like to indicate how different professional and personal backgrounds have informed the values I bring to the scientific research I undertake. The first is my chemistry colleagues, particularly those involved with our growing Centre for Green Chemical Science. This green chemistry movement traces itself back to critiques of industrial chemistry, such as Silent Spring, published in 1962, the year I was born, by Rachel Carson. This landmark publication drew attention to the environmental effects of pesticides such as DDT, and within 10 years the use of DDT was widely banned. I recall arriving as a family to an apple orchard in Nelson in 1973 to find the spray shed full of DDT, which we could no longer apply in the orchard. And I do find so many of my chemistry colleagues deeply committed in their research to address environmental issues, human health problems, and to support New Zealand industries. I also draw inspiration from my theological studies at the Mara Seminary at the Mission Estate in the 1980s. And I took particular interest in the social encyclicals, particularly those of John Paul II on human work, and human work in the context of technological advancement and environmental degradation. And most recently, the 2015 encyclical of Pope Francis, Laudato Si', is all about environmental issues and the need to take swift and unified global action. Thirdly, I note the commitments of my own tribe, Ngāi Tahu, to water quality, to evaluating new hazardous substances, and leading by example with a well-founded climate change strategy. Whakapapa and genealogical research have always been very important to me, and I take great pride in the leadership shown by Ngāi Tahu in these areas. So I see these three sources of influence as being mutually supportive of a greater focus on environmental issues in the future of chemistry, for example. So just some final words of thanks. These include my electrochemical supervisors, John Tomlinson at Victoria University, who introduced me to the electrochemistry of wine and fine wine appreciation, and Graham Wright at the University of Auckland, who guided me into conducting polymer electrochemistry. I'm also grateful to colleagues and students who have accompanied me on these research journeys at the University of Auckland. And finally, to the support of my family, the love of my life, Elena is here, and our son Sasha, and for sharing our life experiences together. So thank you for your attention today.
Thanks very much, Paul. Well, I have the microphone, so I'm going to ask the first question,
Very
which
good.
is, do you have any wine recommendations for us?
Well, as I say, keep your Sauvignon Blanc refrigerated when you find a good one.
Oh, but I have to find my own good one.
Yes, but and New Zealand regions are developing so much more interesting wines. Pinot Noir, Pinot Gris, Chardonnay, they're all worth exploring our regions to try those out.
Agreed, and thank you for that validation of my explorations of New Zealand wine. Are there any other questions? Anyone?
My area of expertise is totally different, but I'm curious, do your methods for keeping the aroma in Sauvignon Blanc also work for things like Chardonnay and Pinot Noir and Pinot Gris?
Well, I'd only point out that if you harvest Chardonnay grapes and Pinot Gris and add antioxidants at harvest, you produce these passion fruit aromas as well. Now, maybe you don't, I think most winemakers don't want a Chardonnay smelling like Sauvignon Blanc, but they will appear if you do. And so, but Chardonnay and Pinot Gris very different in their in their profiles.
Other questions? Well, I do have another one. Can you tell me a little bit about the New Zealand wine industry and how it's is it undergoing a green transformation? Are they thinking about those sorts of things, and how are you helping with that?
Yeah, well, sustainable winemaking has been a big focus of the New Zealand wine industry for many years. And they also support organic approaches and so forth. So they as I said, will legislate or certify growers who follow those principles. So no, it is very much in their mind. And they support, let's say, better use of waste streams as well. And that's where I'm most closely involved with the industry at the moment. Yeah.
Thanks. Well, please join me in thanking Professor Kilmartin one more time.
Cool.